Welcome to True Projects. In this video, we are going to explain about facial emoji avatars. Introduction. The FER facial expression dataset is used by the Facial Emoji Avatars project to train a convolutional neural network CNN that can identify emotions from facial expressions. The initiative seeks to provide an interactive experience by offering a distinctive manner of matching emotions with comparable emojis based on gender. The project improves emotion recognition accuracy and creates avatars that correlate to those emotions by utilizing cutting-edge image processing techniques and machine learning. The system effectively handles dataset uploads, pre-processing, training, and result visualization through a number of modules, providing users with an intuitive interface for analyzing and comprehending emotional reactions visible in facial photographs. Objective. The objective of the project is to create a convolutional neural network CNN model using the facial expression recognition FER dataset that can accurately identify emotions from facial expressions. The trained CNN attempts to recognize and categorize the emotions depicted in test images and then presents appropriate emoji avatar based on the recognized emotion and the gender inferred from the image. The project aims to develop a system capable of automatic emotion identification and customized avatar generation, boosting human-computer interaction through facial cues. It does this by utilizing cutting-edge image processing and machine learning techniques. Requirements. The requirements of the project are hardware requirements and software requirements. In hardware requirements, we have operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above. Software requirements. In software requirements, we have Python IDLE with 3.7 version. Methodology. To implement this project, we have designed the following modules. The first module is Upload Facial Emotion Dataset. This module allows user to input the facial expression recognition FER dataset into the application. Users can navigate their file system to locate the dataset, which likely contains various folders representing different emotions. This dataset is essential for training and evaluating the emotion prediction model. Second module is pre-processed dataset. In this module, the images from the uploaded dataset are read and processed to ensure they are suitable for training the convolutional neural network CNN. The pre-processing involves normalizing the pixel values of the images and resizing them to a consistent size. These steps are crucial for standardizing the input data before training the model. Third module is Train Facial Emotion CNN Algorithm. This module involves the core training process of the CNN model for emotion prediction. The pre-processed images from the dataset are used as input to train the model. The CNN architecture learns to recognize patterns and features in facial expressions associated with different emotions. The training process includes adjusting the weights of the model through multiple iterations epochs to minimize the prediction error. Fourth module is Accuracy Comparison Graph. After training the CNN model, this module generates a graphical representation of the training process performance. It typically displays a graph with the number of training epochs on the x-axis and accuracy or loss values on the y-axis. The accuracy line reflects how well the model's predictions align with the actual emotions, while the loss line indicates how much the model's predictions deviate from the true values. This graph helps in assessing the model's learning, progress, and performance. Fifth module is Predict Facial Emotion. This module facilitates using the trained CNN model to predict emotions from the new test images. Users can upload a test image containing a facial expression and the model processes it to predict the associated emotion. Based on the predicted emotion and optionally the gender of the person, male or female, the corresponding emoji avatar is displayed. This module demonstrates the real-world application of the trained model for emotion recognition and avatar generation. Execution. For the execution of the project, we need to open the code folder. This is the code folder. This is the dataset folder. In the dataset folder, we are having the different emotions: angry, disgusted, fearful, happy, neutral, sad, surprised. And in these folders, we have the images of the respective emotion. This is the emojis folder, in which we have the emojis of female and male, and in the female we are having the avatars of the different emotions, and in the male we are having the emojis of the different emotions. And this is the model folder, which contains pickle and .h file stored, which contains algorithm information. These files can be loaded into the project code during runtime to utilize the trained models. And this is the test images folder. These are the test images which we have used during the execution of the project. This is the main code file. This is run.bat file. Instead of executing the project in the command line interface, we created Windows bat file to execute the project. Double click on run.bat file. This is the graphical user interface which we have created using Tkinter library in Python. Using this GUI, we will interact with the project. Click on upload facial emotion dataset to upload the dataset. Select the dataset. So here we can see that the dataset is loaded. Now click on pre-process dataset to process the dataset. After pre-processing, we will get the total number of images found in dataset, and these are the expressions found in the dataset: angry, disgusted, fearful, happy, neutral, sad, and surprised. Now click on train facial emotion CNN algorithm to train the algorithm and get its accuracy. So after training the algorithm, we will get the CNN facial expression training model accuracy. Now click on accuracy comparison graph. This is the CNN face emotion accuracy comparison graph. X-axis represents iterations or epoch, and Y-axis represents accuracy. And the green line represents face emotion accuracy, and the yellow line represents face emotion loss. With each increasing epoch, accuracy increases and loss decreases. Now close the graph. Click on predict facial emotion to predict the facial emotion. Select one of the face and open. So here we can see the facial expression is recognized as angry, and this is the avatar image for angry. Now close the image. Now let us select one more image and predict the emotion. I'm selecting the fifth, happy. Open. So here we can see the facial expression is recognized as happy, and this is the avatar image for happy. Now close the image and let us select one more image and open. So here we can see this facial expression is recognized as neutral, and this is the avatar image for neutral. Now close the image. Click on predict facial emotion from webcam to predict the emotion. So here we can see that the webcam is on and the facial expression is recognized as neutral, and this is the avatar image for neutral. And here we can see the facial expression is recognized as happy, and this is the avatar image for happy. Now we will close the image webcam. Close the GUI, and the conclusion of the project is: using the facial expression recognition FER dataset, a convolutional neural network CNN model is created in the project to forecast emotions from facial expressions. The methodology for the project entails uploading the preparing the dataset, training the CNN model, and producing accuracy comparison graph. The model's accuracy is growing and its loss is decreasing with each epoch, as shown by the accuracy comparison graph. The model accurately recognizes emotions from test photos during prediction and shows relevant avatars. This experiment shows how well CNN work at recognizing emotions, resulting in precise emotion prediction and avatar presentation based on facial expressions. Thank you for watching the video.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.